Digital case management in companies and government has been done for many decades, and paper archives have been replaced with digital archives. Now, two major efforts are needed for companies and governmental bodies. The IT systems need to be modernized to enable them to exchange and process data across organizations. Processes in the physical world need to be digitized. The last decade have been about digitizing information processes between the users, companies, and public services. As parents, we are already well used to communicate with our children's school through apps and the internet. In Norway, we've come a long way in digital information exchange between government agencies, businesses, and citizens. This gives Norway a competitive advantage internationally, but we have much undone. Let's now discuss further digitalization of physical things that connects the physical and digital world. This is done through small circuit boards that can send and receive data between things and cloud solutions. The more data power that is added into things, the more advanced tasks can be solved automatically in the physical world. Just think about how the auto industry is working to develop self-driving cars. The cars are equipped with powerful computer machines that allow them to drive autonomously. But to train and improve the algorithms to do this, data is transferred to the cloud. To be best at this, Elon Musk and Tesla has offered free internet in the Tesla cars to develop the AI systems that can make cars increasingly self-driving. But to get good traffic flow, we need cars that can exchange information and receive information about traffic conditions, weather, etc., etc. There are abundant opportunities to put small computers into things, and that can be remotely controlled over the internet. Let me mention a few additional examples of things that we can connect to the internet. The first example is drones. Drones with cameras can be deployed to remotely monitor electrical power grids and be used to transport goods, something Amazon has started deploying. Next one is robots. Factories can improve manufacturing processes with 5G. To avoid installing cables all over the factory, this can be now done wirelessly, by that controlling the robots. 3D printing is a technology that is slowly taking off. Instead of putting the production of goods to China, we can produce goods locally. The production of spare parts seems to be an application area that is growing rapidly. 3D printers exist in all sizes, and on the picture here you can also see a 3D printer that is used to print full-size houses. Sensors is something that is built into everything. This can be used to measure air quality, pollution, water quality, flooding, etc., etc. Communication equipment. Today we are using video conferencing and sharing knowledge digitally, as we do right now in this course. But high-quality equipment is still too difficult to use, as it's designed for studio technicians. Thus we have still to settle with inferior quality. Excellent real-time communication of a high-quality video requires that there are no delay or problems with synchronizing the video feed and audio. We expect 5G in combination with new communication equipment and software to overcome such problems in the future. To make full use of a connected digital and physical world, we need to be able to connect things that communicates over the internet anywhere, anytime. For this to happen, we also need much improved battery technology. In recent years, the industry has come a long way in reaching two goals, and that is long battery lifetime and small size. And we know that this will only be getting better and better year by year. As we connect the digital and physical world, a variety of technologies will interact with the 4 categories of technology drivers that we have reviewed. Let me give 7 examples of application areas. First, measuring air pollution to take preventive measures. In Trondheim, we have a research project that are carried out where sensors are placed in the city to measure air quality. Data is sent to a cloud solution where data are analyzed and machine learning models are trained to predict air quality, just like a weather forecast. Then preventive measures can be taken and notification automatically sent to inhabitants. To create this type of solutions, multiple organizations are working together in an ecosystem. And to mention some organizations, the Trondheim Municipality, Tenos Research Unit, the AI Lab at the Norwegian University of Science and Technology, the Norwegian Institute for Air Research, and several smaller companies that specialize in the development of low-cost sensors. Relevant additional data are collected from the Norwegian Meteorological Institute and the Norwegian Public Road Administration. In addition, commercially available technologies are provided by many software and hardware companies on ordinary commercial terms. The next example is measuring water levels in rivers to alert possible flooding. In Nord-Gudbrandsdalen, local businesses, municipalities, and the inland county municipality are testing the use of sensors and artificial intelligence to predict floods so that preventive measures can be implemented. New technology can be used to connect hospitals, primary health care services, and the home to provide better and more affordable health care. With the latest surgery technology, doctors can conduct surgeries over distance using 5G. In Trondheim, the local health administration works with Telenor, Microsoft, and other companies to explore how 5G and edge computing can be used to connect hospitals, primary health care, and patients' home in order to follow up patients through all phases of a disease or surgery. By connecting the home, patients can receive better aftercare without occupying a bed at the hospital. The technology is also tested for use in ambulances so that information about accidents can be transmitted directly to the hospital before the patients arrive. Then doctors can prepare for what is coming. Smart cities are a hot topic. To mention one example within the smart city concept, much research and development is done to develop solutions that allow self-driving car to easily find the nearest parking space. In Oslo, tests are carried out by using sensors built into the street to alert where there are available parking spaces. Information is uploaded into the cloud and communicates with the car. This makes it possible to find the nearest parking space. This is useful for residents right now and in the future for self-driving cars. Monitoring of water and sewage and garbage disposal. Solutions have been developed in Bærum municipality to test water quality. Many people in Norway think water is free, but it's very expensive to purify water. Efficient measures of water quality and whether water leaks from old pipes can lead to huge savings. Safety and remote monitoring. Fire brigades and ambulance services are testing out the use of drones to assess fire and safety. Accidents and fire in tunnels can be investigated with drones that have cameras. This is especially important in the case of a tunnel fire. And the 7th and final example is about transport and logistics, self-driving cars and boats. At Herøya Industrial Park, they are testing 5G networks, IoT and artificial intelligence in logistics operations. One example of the many use cases being developed are solutions to automate loading and unloading of goods to ships. 5G is well-suited infrastructure for such tasks, since 5G has incredibly low latency. At Kongsberg, they have a test project with self-driving buses. These 7 examples illustrate that Norway is now well underway to develop new technology solutions that bring a positive difference for society. Common to all the examples is that each application area requires different and very advanced technologies that need to interact. All the examples involve data exchanged between multiple things and multiple data systems in real time. No single company can master all these advanced technologies alone. The development of new advanced solutions therefore require the interaction of many companies in the creation and operation of new digital solutions in real time. This places new requirements on both public and private enterprises. Common to established enterprises is that they operate a combination of new and old IT systems. The first challenge is to modernize the IT systems so they can exchange data. To make this happen, IT systems need to move either to private or public cloud computing platforms. Information processing can then be further automated, and we will not have to enter the same information repeatedly in different systems. Modernizing IT systems and letting them exchange data in real time will be important for the success of the next promise, and that is to start digitizing the physical world. How the next wave of digitalization of physical and digital world will be experienced? Well, that we are just seeing the contours of. In the next session, we will look at how technology drives changes to the business model.